This is part 5 of explaining convolutional neural network. This is the most interesting part where we will get hands-on example of using CNN to image classification. First of all, let's see what is the building blocks of a CNN. Convolution and pooling operations are used to build the layers used in CNNs. In CNNs, typically you can find the following layers: convolutional layers, pooling layers, and fully connected layers. The fully connected layers are a layer where neurons are connected to all neurons of previous and subsequent layers. Convolutional layer takes an input, a tensor, which can be three-dimensional due to the three color channels. For example, an image applies a certain number of kernels, typically 10, 16, or even more, adds a bias, applies ReLU activation functions, for example, to introduce nonlinearity to the result of the convolution, and produces an output matrix B. A convolutional layer is always followed by a pooling layer. Sometimes the two together are called a layer. The reason is that a pooling layer has no learnable weights, and therefore it is merely seen as a simple operation that is associated with the convolutional layer. Let's start with some coding. We will develop a very simple CNN and try to do classification on the mnist dataset. The mnist database contains 60,000 training images and 10,000 testing images. We start with the usual importing necessary packages from TensorFlow, and then to load and import the layers and models from tensorflow.keras, and to import the mnist dataset from tensorflow.keras.datasets. Then loading and pre-processing mnist dataset. This is the function to load data from mnist to get the xtrain and ytrain, xtest and ytest. Then we normalize pixel values to be between 0 and 1s. And then reshape for CNN input. We want first parameter to be the batch size, then the height, the width of the image, and then the channels, the RGB colors. And if it is gray, so the channels is 1, equals 1, which is the default. Then to build the CNN model, we are using here the sequential model, and then the layer conv2D, which contains the 32 first parameter, and then the kernel, which is 3 by 3, and then activation to be ReLU, and the input shape to be 28 by 28. This is the image, and then because it's a gray scale image, so this is equals 1. And then the max pooling 2D to be 2 by 2, and another convolution layer to be 64, and this is the size of the kernel, and the activation function is ReLU. Then a max pooling layer. Here we are flattening the layer to be suitable for the dense layer. This is the fully connected layer, and then lastly the fully connected output layer with 10 classes, and we are using here the activation function equals to softmax. Then compile the model using compile method from model, and I'm using here the Adam optimizer, the cross entropy loss function, and the metrics to be accuracy. Then to train the model using the fit method with xtrain and the ytrain, this is the labels, with 5 epochs, and the batch size to be 64. This is after training the model with 5 epochs. To evaluate the model, we can use evaluate method, and we will get the test accuracy, which is here about 90%. To make prediction, we use predict method with the xtest, and I'm using the first label here, and then to predict label with the argmax prediction variable. So here the predicted label is 7, and the true label is 7. So this CNN learns features automatically from pixel data and classifies handwritten digits using the mnist dataset.